and then we're gonna move on, okay? It's okay if you don't finish. Okay, I just wanted you guys to practice a little bit. Let me make sure it's recording. Okay, so most people got the zeros correct. Let's see, I think you guys got -1, right? -4. And then here, some people were rewriting this as x plus 3 and then x plus 3, which is fine, that's correct. But they both do give you the same 0, which is -3. Okay. I'm going to copy some of a method that a lot of you guys are doing, which I like. So some people are doing it like this. They're saying the x values here. Here's -4, here's -3, here's -1. And like, let's say that here's the y-axis. All right. So the point of this is you don't want to plug these back into the function because that'll just make them 0. That's why they are called the zeros. So we know the graph is going to, it has to touch this point. These are where your x-intercepts are going to be. So then you want to use values that are going to be between these intercepts or these zeros to help you determine if y will be positive or negative. So a lot of people are using -5 for this one. But here's where I'm seeing some mistakes, so be careful. If you plug in -5, you're going to plug in -5 here, here, and here. So it's going to look like this. Okay. You don't care about the actual numerical value, you just care if it's positive or negative. So what is this going to give you? Negative. This guy? Negative. And this one?
Positive.
It's a negative, but it's being squared.
Positive.
So it's going to give you a positive.
Negative times negative.
And then a negative times a negative is a positive. That's why I think people are making a mistake. Negative times a negative is a positive. So then you really just have a positive times a positive. So it's a positive.
So this is what we're going to see.
So from here, yeah. So from here, what people are doing is you're kind of splitting it up like this, which is really good.
So when you break it up into x plus 3, because technically that's correct. How do you, like if you wrote it like that and forgot to square it, how does that then give you?
So it looked like
Okay, so
that.
it's still the two negatives are separate.
It would be two separate negatives that give you a positive.
Oh.
Yeah. So that means that the y value is going to have to be positive. So the way we were doing this on Monday was we were saying, does that mean that the graph is going to be below the x-axis or above the x-axis? It has to be above because this means the y values are positive on this interval.
Yes.
So we cross off
The bottom.
the bottom. We do not want the graph to be on the bottom. Okay. For the middle, some of you were avoiding it. You have to plug in a test point that's between -3 and -4.
3.5.
It has to be a decimal. So -3.5 would work. Let's do that real quick. Let's see. So you plug in -3.5 here. What kind of number do you get?
Negative,
You get a negative. Here you'll get a
positive.
because 4 is bigger. And then here, no matter what you plug in, you're going to square it. So it's always going to be positive. So now you have two positives multiplying each other times a negative, opposite signs, negative. So that tells you that the y values have to be below the x-axis. So you do not want the graph to be up here. Okay. If you use this test point, what did you guys get?
Above.
You got above?
Negative, positive, positive.
Oh, let's check. So plug in -2 here. What do we get? Negative. Plug in -2 here. Positive, and then positive.
Cross out, yes.
So you got a negative times a positive. Negative. So we do not want the graph has to be below, so it cannot be above. And what's an x value you guys use greater than -0? 0. Yeah, use 0. So you plug in 0, you're going to get
Positive.
positive,
Positive.
positive, positive, so it's all positive. So the graph is gonna have to be above the x-axis, so it should not be below at all, so you cross off that area. So that tells us that our graph has to start from here. It has to touch that point. Can it go back up?
No,
No, it's gonna have to go down,
but it has to touch -3.
but it has to touch -3.
I mean, it has to go back down and touch -3.
Correct. Once it does this, let's just kind of give it a sketch here. So let's say it looks something like this. It has to twist back up because it has to touch this point. Does it then go up? No. Can I draw that?
No.
No, because remember, polynomials don't have spikes. Okay, all that is summarized in the page before it, by the way. Everything we did is summarized here. So it can't do that. It has to do a nice curvy twist, remember? So it's gonna have to do some kind of nice little twist like that.
If you are on the test and you like can't not, can you just put not curved? You put a little label. That like. round it, like-
If I see that, no, I'm marking points.
Okay, but if you tried.
I'm gonna just. That actually, the reason I'm being anal on that, guys, when you guys learn derivatives, funky stuff happens to shapes like this or like that versus this. The derivatives are gonna be different for that, so I need you guys to have an eye for that. Okay? All right, so it can't go up, so it has to go back down, but then it has to touch this again, right? Does it do a twist down again? No, it has to go up. Now you have to then find the y-intercept. Big GER. So if you guys turn around on this page, we did step 4. Now step 5 says find the y-intercept. Plug in x equaling 0. Okay. You guys plug in x equals 0. Let's see, what do we get? You're gonna get 1, 4, and 3 squared. So that's 4 times 9, 36. So this
So
shit's gonna,
basically, if you, because what I did, I solved for all of them. I plugged in the numbers and got like the real number.
Mhm.
So I already got 36, because when I did f of 0, I gave me 36.
Yeah, yeah. So third, you know, the graph has to cross here. Okay. After it crosses here, does the graph twist and go back down and hit the x-axis? No.
It is
You do know it can't hit the x-axis again. Because if it hits the x-axis, that should have been one of the zeros that you got. That's how you know that. The only time it touches the x-axis is here, here, and here. That's it. That's what the algebra is telling you.
So now approaches infinity.
So then it'll just shoot up.
So we have to have arrows on that one and the other one.
Correct. Yeah. Correct. Okay. Yeah.
The point minus 3.5, is it like negative? Because when I plug the minus 3.5.
Oh, here?
Yeah.
Let's see. So if you plug in negative 3.5, it'll make that negative. Negative 3.5 plus 4. The 4 is bigger, so it'll be positive. And then a negative 3.5 plus 3 is a negative, but then you're going to square that negative. So it becomes positive. So if you multiply all that out, you're going to get a negative. It'll have to be negative, yes. Okay. Your problem set is going to ask you to do one of these problems. So that's why I want you guys to practice. I was like, no, let me spend a little bit of class time. And I'm going to post the solutions to all these. There's 4 problems to work on. Okay. All right. But we do need to move to the next section, guys. Right here. But this packet is a summary of Monday. So if you weren't here on Monday, this is basically what we did. All right. Okay. It's weird that we went from chapter 4 to chapter 13. Okay, But I'm telling you a story as your instructor, okay? And so I have to look at the textbook and I try to figure out what's like the best way that I feel that I can tell you the story. So we talked about polynomials. On the problems that lie ahead, this problem that I gave you, this is an easy problem because it's factored. Okay? But if you look at the ones after that, those are not factored. You have to factor them yourself. Okay? But then there's an issue because sometimes the methods that you guys learn for factoring won't work because the polynomial is too complicated. So then it's going to be too hard to find zeros. Okay? Because once I factor it, I can find the zeros right away. But if it's not if I can't factor it and I can't use any of my techniques, how do I find a zero? So we're going to travel to chapter 13, and there's a little bit of theory that helps us with that. Okay? All right. And you guys are going to be introduced to your first, at least in this class, our first theorem. Let's see what that looks like. Right. Okay, so we're gonna let's see. Fly to chapter 13.1 all the way to 13.3. I'm not covering everything in 13.1. I'm not covering everything in 13.2, and I'm not covering everything in 13.3. Only the pieces that we need for this class. Okay? Because those sections are hella loaded. Okay, what did I call it here? I'm gonna give it a better name. So we're gonna introduce what's called the fundamental theorem of algebra and something called the linear factor theorem. It's a little, hold on, camera. There you go. Okay. So let me just start with some remarks that are important when we're dealing with polynomials. So the first one is it's important to find zeros when working with polynomials. A very important thing we need to know. And the other thing that we saw last time on Monday is that when we were factoring and solving, you guys remember how we had an example where sometimes the zeros were imaginary numbers?
Yeah.
Okay, so that can creep up. And that just meant that it's a zero, an imaginary number 0, but it did not contribute to an x-intercept. Okay. And so then we noticed that some polynomials have zeros that are real numbers or complex numbers. And remember, just from the first week of class, a complex number looks something like this. It's been a minute since we looked at that. So something like this. Yeah, like when you guys use a quadratic formula and stuff, sometimes you get numbers like that. Okay. And then the other thing was a little bit of vocab. Another name for the zeros of a polynomial are its roots. or its roots. So when you guys were looking for the zeros of a polynomial, you're setting the function equal to 0. And you're looking for what x values make that equation equal to 0. Another word for that is the roots of that equation. Okay? I'm saying that because these theorems use the word root instead. Just like the zero. Okay. So this first theorem is going to answer the question, if I give you guys a really disgusting polynomial, like let's say degree 5,000, and it's just hella long and hella big, and I set it equal to 0, does it have a solution? Or will there be no solution? Can there be a polynomial so that when I set it equal to 0, there's just no solution? There's no way to find it. Okay? So that's what the first theorem is asking. Here's my question. Does every polynomial have a 0? If I set it equal to 0, is there a solution? Every single polynomial that exists that you guys can picture in your head. Okay? And so this first theorem is going to answer that question. Fundamental theorem of, oops, not calculus, of algebra. You're going to learn that when you get to calc. And this is what it states. It says every polynomial has at least one root, x equals r, where r can be a real number or a complex number. And so this theorem says yes, every polynomial that you can think of that we're going to deal with in this class, there has to be at least one solution. Every single one, no matter how big the degree is. Okay. Right now, you guys are in a college math class. Okay, you're in what's called a lower division math college class. When you transfer to university, you then take what's called upper division math class. Okay. In a lower division math classes, you're going to see hella theorems. Okay. But most of the time, not all the time, most of the time, the theorem is a tool that you use to help you solve a problem. Versus in an upper division math class, a theorem is the problem, and you have to prove it. Okay, so that's like a big difference between a lower division math class and an upper division. So here I'm presenting you a theorem, and we're just going to use its facts. And we're going to use the information that it gives to help us answer the question. Versus if you're at a university and I show you this theorem, part of the homework might be proving it. Okay, that's the difference. And most math theorems have kind of what's called like a logical statement where it says like, if this is true, then you get a freebie, and you can then conclude the rest of what I have here. So in this case, see, it says every polynomial. So we have to deal with a polynomial to begin with. So if I give you guys this equation, you don't have to write this part down, but like let's say I give you guys this equation. Just making shit up now. Like that. Will it have a solution? I don't know. Can I use this theorem?
No.
Why can't I use this theorem?
It's not a problem.
Because it's not a polynomial. So this theorem says, first I have to figure out what I have. If I have a polynomial, then I can then conclude what? That it has at least one. So that's how you're gonna use a theorem in the math class, okay? Okay, so here, I can't use this theorem because I don't have the beginning condition met. Not a polynomial, so I can't say anything about its solution. Okay? Hold on. Okay. So we also noticed that the root of the root x equals r of a polynomial corresponded to one of its factors. And let me show you what I mean by that. Another thing we've been noticing. So like, let's say, this is one we did on Monday, okay? We had x cubed plus 3x squared minus 4x minus 12. We factored this one on Monday. It was factored by grouping. Okay. When we factored it, we set it equal to 0 to find the zeros. And when we were done factoring it, we ended up with something that looked like this. Okay.
I have a question.
Yeah.
When do we, so when we factor in this case, do we always set it to 0?
When you're finding the zeros, of the polynomial. Because we're trying to see what x values give you a 0 y value.
Okay,
So yes,
in the beginning, how we got one that wasn't factored out, could we be given an equation like that, like -2x squared at 4x at 16, and then have to find 0, or?
which one are you looking at? Oh, like another problem?
Yeah,
Say that again,
if it, -2x squared at 4x at 16,
Negative 2x squared.
at 4x at 16.
Okay, like if that was a polynomial that you're dealing with?
Yeah, do we find the x's and then set them to 0, or what do we, like, can this be an equation that we have to solve, or?
No, this is the function. Then you gotta ask yourself, what am I going to answer? If I'm trying to find the zeros, or if I'm trying to find the x-intercepts, yes, you set the function equal to 0,
The whole thing,
the whole thing.
and then from there we expand out the language.
And then here you try factoring to help you find these x values.
Okay,
But that's if you're trying to answer what are the zeros of the function, or what are the roots,
okay,
okay?
okay, so it depends on basically what it's asking.
Exactly. If it says, if instead I said, what is the y-intercept? That conceptually is something else. Now you're trying to figure out what happens when I plug in 0 into the function. See, that's different.
But if you ask me to factor it, then I would factor the factors that would lead me to finding those zeros.
But factoring would help you get those zeros. Correct. Yeah, so there's like all these questions that are being asked about polynomials. So you gotta be like, what's the question asking me to do? Therefore, how do I start proceeding to answer that question? Yeah. Wrong.
So you said so, only setting to be 0 when you apply zeros and what else?
So, yeah, maybe we can write this over here. It won't be on the recording, but so x-intercepts. No, actually, you know what? I want to squish it somewhere. Okay, maybe I'll do it here and then I'll erase it. Okay. So there's the zeros, right? That's when you're trying to set, you're trying to set the function equal to 0 to help you find what makes that equal to 0. Like you're answering this question here. What do you plug in to make the function equal to 0? Roots is the solution to the equation that you create when you set the function equal to 0.
How many x's will be crossed in the graph? Is roots.
Yeah. So the roots are the solutions to the equation. So it's talking more about the equation you're solving. 0 is talking about the input x values that make it equal to 0. So they're kind of saying the same story in different ways.
So I was-
They're the same. They're the same values, but roots are talking about a solution to an equation. Zeros are talking about x input values that make it equal to 0. And then there's x-intercepts, which are
The zeros.
the zeros where the graph crosses the x-axis. Where does it cross the x-axis? On the zeros at those points.
You need the zeros to graph it, which is why that's important.
Yeah.
Okay, and then real quick,
So the roots are the zeros, which is the point x comma 0.
well, I mean, I know how to find the y, but is it which x is it gives you the y? Is it the biggest x or the smallest x?
Say that again.
Which x gives you y?
Which x gives you?
Yeah, like, you know how x, I mean, y was just 36 in this one? Because we solved f of 0 and.
That's when you're finding the y-intercept.
Don't you have
Yeah,
like
but which
function?
x do we?
It doesn't matter, does it?
to get y?
Well, to get the y-intercept,
Just, yeah.
so see, to find the x-intercept,
It's hard to.
the y is equal to 0, right?
Okay.
So that's why we set the function equal to 0. Because y is going to be 0.
So to find the y intercept, we just do f of 0 and then that would.
Because here x has to be 0. Exactly. Yeah. Yeah. So they're all kind of sounding the same, but they're all doing something a little different. So good questions. Okay. So if I'm trying to find the zeros of this function, I set the function equal to 0, and then I have to factor it to help me find those zeros, which as the solution of this equation is what's called also the roots. Okay. So in this case, what are the roots of this equation, or what are the zeros of the function?
-2,
Okay,
-3.
and -3. So this is what I mean by this comment. So we're noticing that that the root of this equation, or the zeros of the function, if I know this root, I know that the function factors in such a way so that this guy shows up. You see what I mean by that? So let me do this. Let's say I gave you guys a different function. Okay, we don't know what this equals, but I know that a root of it is 5. Okay, I know that one of the roots of this function is 5. If I was to factor this function, what factor will this guy correspond to? X minus 5 has to live there. It has to live there. Okay, because that's what produced that root, or that 0. Okay. What if I had x plus 5, x minus 5? Then there should be, it factors in such a way that x plus 5 will be one of the factors. Okay, and that's not a consequence. Okay, that's a pattern that should be happening. And so that's what the following theorem is going to say. So this guy is called the linear factor theorem. it says, let f of x be a polynomial. We have to be dealing with a polynomial. Comma. Then if I plug in a number r and it equals 0, what's the name of this number here? What are we calling it? If I plug it into the function and it gives me 0,
Is that the roots?
it's a root. Or it's a 0 of the function. Okay? So if I plug in a number and it gives me 0, so then this will equal 0 if and only if, I'll explain what that means. X minus r is a factor of the polynomial. So it's kind of what we were doing here, what we were playing around with. Here. So when you guys read this right here in a math class, this statement, if and only if, this is what it means, okay? It means that if I plug in a number, if this is the 0 of a function, okay? If this is true, then it'll tell me, it'll conclude that the function has to factor in such a way that it looks something like this. I don't know what the rest of the stuff is, but I know that one of the things it factors into is that. And then vice versa. If my polynomial factors in such a way where this is one of the factors, then has to be a root. Or it has to be a 0 corresponding to r, so that it tells me that this must be true. Okay? What if I plug in a number and this is not true? Then it cannot factor into in such a way that this is one of the factors. Okay? What if I factor it and this doesn't happen? What can you conclude? That's not true. So that's what this if and only if thing is saying in math. It means that whatever the case is for this, if this is true, this is true. If this is false, this is false.
But does that have to equal 0 at some point to be a polynomial?
But exactly. But then this theorem says, well, you know what? Will this happen at some point? It has to happen at some point because there's at least one root. Exactly. That's how they talk to each other. The two theorems. Okay.
So that the fundamental one's just saying it exists, and then the linear is testing which one is it that makes it exist.
Exactly. And so that's kind of where we're going, because if the polynomial can't factor, like let's say I don't know how to factor it. The methods I've learned don't show me how to factor it. But I know one of the roots has to exist. Whatever that root is, this theorem tells me this is how it will have to factor in such a way.
So then what is r?
That's what we're gonna get to. Okay? That's what we're gonna get to. Let's take a break though.
What is our not the root?
Huh?
Is our not the root? Is our root?
R is the roots, yeah, but Alexa's question was like, how do we find it? Though?
Oh,
Like, can you use that with any equation? So can we put that back into the example? Like, can we use it with a simple polynomial?
We're gonna play with some in a little bit. We're not done. Yeah, let's take a break though. That was a doozy. So come back at 2:02. Yeah. what's up? Tell me what you want to do. Hey, just like, yeah, what it comes to, There's a different decimal one. You're not putting in -3 over 5. You're putting in -3.5. Yeah, because -3 over 5 is the decimal number 0.6, which actually lives here, which is a little positive.
Yes.
Yeah.
Another question, how can you add on the zero?
Is that -3 x plus 2?
Yeah.
So for that one, so you want to factor if you have multiple terms with an x on it. But if you only have one term with an x on it, you just isolate this guy. Meaning you move the 2 to this side by subtracting both sides by 2 and divide the -3 off. So you don't have to factor it. Because now to undo the fourth root, you do the fourth root of it. Sorry, power 4, you do the fourth root to both sides. Yeah. Okay. Is it 2? Okay. Oh, dang. Okay. Bring it back, bring it back. So we were discussing the difference between what a root and a zero is, in case you're still a little confused. A root has to do with an equation, and a zero has to do with a function. Okay, but they're kind of telling a similar story. So for the question, what is the solution to this equation? You would say the root x equals whatever it is. But if I wanted you to do the same thing, but I worded it in terms of a function, I could say, for which x values does the function f equal 0? Now that's a function question. So then I would say the 0 x equal blah blah blah. Okay, so they're both vocab words that are giving you the same number, but they are answering a different question. Okay, both of these, both the root and the 0 will equal the same thing, and they'll both correspond to the same x-intercept. Okay. Okay. All right. Let's keep going. Okay. Whew. It's a doozy. Okay. So this theorem says every polynomial has at least one root. Now, it doesn't say it has to be a real number, though. It means that root, can be either a real number or a complex number. So it's possible that it's just a complex number. Okay. If it's just a complex number and that's the only root for this thing, then the graph will not cross the x-axis because it's giving you a complex number. It doesn't correspond to a real number on the x-axis. Okay? Okay. This theorem says, okay, if x equaling r, right? If I plug that here, this is one of the zeros for this function, then we can conclude that this polynomial factors in such a way that x minus r is one of its factors. Okay? And so I just wanted to add a little bit. This factor may show up multiple times if x equaling r has a larger, here's another word we did on Monday, multiplicity. If you weren't here Monday, that just means that this number R is a zero for the function multiple times. You'll see what I mean. A lot of vocab, I apologize. Okay, too much talking for me. I want you guys to do a little bit. So let's see, let's try to put this together with an example here. Okay. So consider this polynomial here. X cubed plus 3x squared minus 4x minus 12. The one we kind of been playing with a little bit. Here's the first question. Which x value is a 0 for f? X equaling 1 or x equaling 2? And then how would you check that? And then once you've checked that, what can you conclude about how f of x factors? If I was to factor it, what can you conclude about how it'll look like? Okay. Which of those is a 0 for f? How can you check that? That's important. How can I check if it's a 0 for this function? And once you answer question 1, that'll help you answer question 2 using what we just discussed with these theorems. Notes I want to write down in this one. All right, guys, and just checking with each other. How can you confirm it? How can you confirm it?
Remember I did B.
You don't need that.
No, man.
Don't factor it, guys. Don't factor it. To answer question 1.
It's just did a B on.
Can I just plug in one of them into where they exit? That's plug it in.
So you're putting it in the window.
Yeah, I mean,
And then you guys just.
And so you got to have a couple more consider what it's very.
Right.
I just put in. Minus two.
Yeah.
And then. So X minus. Minus two.
X, you know, X.
Because
You could put on, so yeah.
So like two dollars.
That would be. I don't.
Yeah.
X, we can give it back.
Okay.
Okay, guys, so which of the, what did you guys do to check to see if it was a zero? Plug it in, plug it in. So if I plug in one, right, well, I want to check this guy. You plug in one, did you guys see what you got?
Negative.
You get -12, yeah, you get 1 cubed plus 3, and then you square that, minus 4 times 1, minus 12, and what did you get?
Negative 12.
Minus
Well, it's negative.
-12, okay, which is not equal to 0. Okay, that's what you guys are saying, okay, good. So is that a 0?
No.
No. And then when you plugged in 2, what did you get? You plugged it in, and then you would get 0 in this case. So check. That gives you, that means that when I plugged in 2, I got 0. Okay, to answer question 2, notice that that is kind of what this is talking about. If there's a number that I plug into the polynomial and it gives me 0, then I can conclude that the polynomial has to factor in such a way so that this factor shows up. Okay, see how this guy's one of the zeros? So by the linear factor theorem, since f of 2 equals 0, that is equivalent to me saying, two-sided arrow, that the polynomial is going to have to factor into as how? X minus 2. And then what's over here? I don't know. I won't know. So your textbook will just write a different like polynomial function. Because we don't know what that one is. We just know this guy has to show up. That has to show up. That's what that theorem's saying. Okay.
So where does it come from if you don't have multiple choice? Like if you're not given ideas of what to plug in, how do you find?
Okay. Perfect. Great question. So this is the timeline. Okay. Or like not the timeline. This is the path we're going to go to now. So what we're going to do is it's helpful to know if we already have one of the zeros, because we know it's going to have to factor in such a way that's like this. So there's two questions we're going to answer. One is how I want to keep going. I want to be able to factor this thing here. How do I find g of x if I know this already? And I know that this is one of the roots. How do I find g of x? Okay. But then Alexa's question is even like before that. How do I even know what I can plug into the polynomial to give me a 0? That's what we're going to do on Monday with another theorem to help you find like possible x values that might be a 0. Okay. So right now we're just going to answer the question, how do I find this guy? So I know that this polynomial, this tells you here that this polynomial, x to the 4th plus 3x squared minus 4x minus 12. Did I mess up?
To the third. Next to the third.
Oh, x to the 3rd, thank you. We'll factor into something like this. Right? This is the function. This is f of x, and it'll factor. So the question now is, how do I find this guy? Okay, how are we going to find it? What degree is the polynomial that we started with?
3.
You were here Monday. How did you know it was 3? The largest exponent. Okay, so we know that the polynomial is of degree 3, and when I factored it, it's x minus 2 times this. What degree will g have to be? It'll have to be degree 2, because when I multiply this guy with x, it better give me something that's x cubed. See that? Okay. But now that's the question. So that's where we're gonna go now. Is like, how do I find this guy? How do I find g of x?
So then.
Yep.
So then one of G and X squared.
It'll be some quadratic, x squared something. Yeah, but which one? How do I know which one? Yeah. All right, let's keep going. We're reading a good story right now. It's a little complicated because you're basically in like 40 minutes learning like 30 years of theory. So continue from here. So notice that since f of x factors into something like this, where g of x is a smaller degree polynomial. In this case, it's 2. So the question is, how do we find what g of x equals? What operation? No, what is x minus 2 and g of x doing? What are these two things doing to each other?
Multiply.
They're multiplying. Okay. So what we're gonna do,
Divide x, subtract 2.
I want to find g of x. So we're gonna divide f of x by x minus 2. Because that's the opposite operation of multiplication. So here's the answer. So since division is the opposite of multiplication, g of x must equal whatever f of x is divided by x minus 2. So that means we're gonna have to get this nasty polynomial here. And we're gonna figure out how we can divide it by x minus 2. And the section 13.1, it actually starts with dividing polynomials. Shows you how polynomials divide, but they divide it in, do you guys remember long division that you guys learned in elementary school? Like this notation?
Yeah.
And like you guys had, remember you did that and there was like remainders and all that stuff? Okay, that's, the textbook covers that type of division. Hell tedious. Okay. I'm not gonna cover that type of division. Because we just don't have time to do this. But we are gonna cover a specific type of division when you're dividing a polynomial by a linear factor. Because that's all we're gonna have to deal with, because we're always dealing with linear factors. Okay? Oops, careful. So this part here is called synthetic division. So we will only focus on dividing. Sorry for all the writing, guys. Polynomials by linear factors with a process called synthetic division. And let me show you what that looks like. So much writing, sorry.
What does synthetic mean? Fake.
Say it again.
Fake.
Fake? Yeah. So it doesn't, at first it doesn't appear like you're doing division, but in reality, the theory behind what's happening is that there is division. Synthesizing division. Yeah. Okay. So let's do it to this guy here.
No, I'm sorry.
Okay. But let me wait, because that was a lot of writing. Okay, here we go. So let's see, let's actually continue with this one and let's divide. X cubed plus 3x squared minus 4x minus 12 by x minus 2 using synthetic division. Okay, so I'm gonna hella label this one for your notes, okay? So the way you start this is you identify the roots. What is the root corresponding to this linear factor? X equaling 2, right? So you're gonna get that root, which is x equaling 2, and then you're gonna write it in its own little house. Like that. Okay? It's gonna look really weird. That's why it's called synthetic division. Okay? Then what you're gonna do, you're gonna divide this guy by this one, but it turns out all we're gonna do is use the coefficients of the polynomial. So then what you're gonna do is you're gonna grab the coefficients only, and you're gonna put them horizontally in descending order. Okay, what's the coefficient of this term? 1. What's the coefficient here? -4, -12. Like that. Okay. It's throwback.
I remember this.
Okay.
Actually, this is pathetic.
Okay, so here's how you start it. You draw a horizontal line, and the very first step is whatever that leading coefficient is. In this case, it's 1. It drops straight down,
And then do you add that to the next one?
and then you get that number down here, and you multiply it with 2,
Yeah,
with what's in
I
the box.
remember now.
So 1 times 2 is 2, and then you write it over here. So this is 1 times 2. This 1 times this 2, and then
Basically.
you're going to, in this case, you just add them straight down.
Down.
Okay.
So, sorry,
Yeah, it's okay.
so you'd first do the leading coefficient, then.
Bring it straight down,
Multiply it by the,
the root in this case,
and then add it under the second one, then add it and bring it down.
and then you just start that pattern over and over and over. So then you do 5 times the root, 10. And then you add straight down, +6, and then you just repeat. 6 times the root is +12, and then when you add straight down, that's how you know you're doing this right. Because this basically in division tells you that you have a remainder 0. So it divides evenly. This divides evenly here, whatever that means.
Bring
Okay,
down, add.
what does this tell you? Now what? Okay, so this tells you now that this are the coefficients of g of x, this guy that you were looking for. This original one. Your constant term is going to be 6. And then the next one is x to the power of 1, so 5x. Your degree 1 term. And then 1x squared or just x squared. Okay. And so it's correct. What we were guessing, we had to get a quadratic, and it turned out it's a quadratic and it's that quadratic. Okay. obviously, this guy here is considered the remainder. But because we know x minus 2 divides f of x, it will have to have remainder 0.
So we're adding up.
You add straight down, correct? You add straight down. So somewhere in your notes, yeah, you basically, you're gonna add straight down with these two. Or maybe actually, let's go like this. Just put the plus. Yeah. Now, what does this tell me? Remember, my original goal was factoring f. Okay, now we found g of x. So this tells you that your function, therefore, has to be x minus 2 times this quadratic. Like that. Okay. We have a quadratic. So if I wanted to, let's say I wanted to find all the zeros of f, I already know one of them is 2. So now I just use this one and help and keep going. But we're gonna stop here for now. I just want you guys to practice this part. Let me say what I said again. The original bigger goal is to find the zeros of the polynomial f. What we just did is we know one of the zeros was x equaling 2. So we know it has to factor into x minus 2. We didn't know what this other guy had to be though. So we use synthetic division to divide the original function by x minus 2 to produce that g of x. And then we put that together to then say, well, that g of x then is what goes right here. Okay. All right, I'm gonna do, yeah, Rohan.
So then where did you simplify in the x squared plus 5x+6?
You can keep going.
To get the zero?
Exactly. You can keep going. Correct. Alexa.
And then why wouldn't the factors, because I know the answer, but why wouldn't the factors be 5 and 1? Because it has to multiply to the middle and add up to last, or?
Oh, you mean if I wanted to keep factoring this?
Yeah,
You can keep going.
yeah.
Yes.
But why would it not be 5 and 1 as the factors?
It could, yeah, no, I mean, if you factor this, I believe this is,
X plus 2 and x plus 2.
It's x,
Oh.
plus 2, and then, just this one over.
oh, no, you're right, plus 3. It wouldn't be 5 and 1 because it won't add up to 5x.
Okay, so they have to add.
Yeah, correct. Okay. All right, now I want to just work on being able to find this g of x, okay? I'm gonna do one more, and then you guys are gonna do 3 of them. Okay? Slay. All right. Okay, one more. That's gonna be a little weird. That way you guys have 2 examples here. Okay, so let's divide x cubed minus 6x plus 4 by x minus 2. Okay. All right, so let's see. What's my root? My root is 2. Here the root is x equals 2. So I bring that sucker down, put it in its little house. And here you gotta be careful. This is why I'm showing you the second problem. Here you gotta be careful. This bad boy here is missing some terms in terms of like the powers of x. Right? That's this guy's a degree 3. But it's missing a degree 2 one. So what's happening is that it's 0, it has a 0 coefficient. Okay?
Oh,
Yeah. What about the x term? Is it there?
no.
Oh, yeah.
It's right here. So I bring it. And then I have my constant term. But you got to be careful. If you don't see, if you're going in descending order and one of the terms is missing, it really has coefficient 0. So if you don't put that in this, as part of the coefficients, you're gonna get it wrong. So is that 0 here that was hiding?
Right.
So what are the numbers that we're gonna list here, guys?
4, 6.
Positive or negative?
Negative is and 4.
4, correct.
Wait, I'm still confused.
Yeah, no, go for it.
That 0, is it from like,
It's because it's not here.
oh,
So in reality, that means that the x squared term has a coefficient 0, which made it vanish.
oh.
Okay. So if like, if don't do this on your notes, guys, but if this guy was missing and it was just x cubed plus 4, then it would be x cubed.
Mhm.
There's no x squared term, so it has coefficient 0.
Zero.
And then this guy would also have coefficient 0.
Oh, okay.
Yeah, so whatever's missing is
Good.
being disguised with coefficient 0.
Okay.
Okay, so let's see. So I bring this first leading coefficient down. We multiply it with the root 2. You add straight down 2. Then I multiply this result with my root. You add straight down and then multiply that with my root. And it has to give you a remainder 0 because well, and the problems I'm going to give you will have to have remainder 0, okay? Because of what we're doing. We're trying to factor this guy here. Okay, so this is my remainder. This is your remainder. Now here you end up with your polynomial here, which is going to be x squared is 2x minus 2. Okay. So this tells you that this original polynomial x cubed minus 6x plus 4, imagine I asked you guys to factor this. Take a look at it for a bit. It's not a quadratic, so I can't do what we normally do, like the box method or the AC method. It doesn't have 4 terms, so I can't do factor by grouping. So there's no methods. Substitution stuff, no fancy stuff. There's no methods that we have to factor it. But through this process, because this gave us remainder 0, I now know that this linear factor times this quadratic must multiply to this degree 3 polynomials.
And then on the test, will you give us like a hint, like in the section, be like, use the synthetic division to solve this problem, or do we have to just kind of recognize that that's x cubed?
I probably will, yeah, I probably will,
You'll help us.
yeah.
Thank you.
Okay. So, any questions? Yeah.
This case, the was 0x squared, but there is no final answer. Is it because us? You just basically factored out that's why I squared it.
There is a 0x squared.
So in the original one, there isn't an x squared term, right? Which is, like you mentioned, see how there's no x squared term? But you're saying in the result there is?
Yes.
Correct, that is right.
That's why.
Because it's being, yeah, because it turns out that when this actually factors, the 2 factors, one of them will have a quadratic.
Yeah, because that
But then how would you
make it x squared, right?
Yeah, because notice right here, watch, let's say I multiply this out, yeah. There's this guy here, that would be negative 2x squared. But then when I multiply this one with this one, it's positive 2x squared. So those x squared terms vanished. And
Oh,
to
well,
give
like-
to my final result.
0x squared, all right.
Correct.
But like, how would you have known if you see it?
You wouldn't have known to do that. That's why we're learning this, because sometimes factoring is really hard.
Yeah.
So this process shows us, if I know one of the factor, like if this gives me remainder 0, then it has to be one of the factors.
Can you use this method all the time?
You can use this method all the time as long as you get remainder 0. If you do not, then it doesn't work.
So if you don't get a remainder, you're then use it.
Correct.
And then if the factors are even like, when we split it, like when there's 4, now we're gonna split it in 2, and then the ones in the parentheses are supposed to be the same.
Correct, yeah.
Do the ones in the parentheses that are the same have to go in the front? Or does?
No, it's okay. No, yeah, no.
Okay.
Yeah. Okay. Beautiful question. Let me give you guys these three, so you guys can practice. That was too much talking for me, I apologize. All right, let's see. Use synthetic division for the following here. So for number one, do 3x² minus 5x minus 2 is over x minus 2. Second one is x⁴ minus 3x² minus 4 over x plus 2. And then x³ plus 27 over x plus 3. Yeah.
So. No.
Use synthetic division, see what happens.
So the bottom part, if it's, it doesn't matter if it's like x subtract 2 or x plus 3, or usually like 2 or 3. If you do
Yeah, so whatever your the linear factor is, you're gonna want to use the root of it.
So just 2.
So just 2, or like the opposite sign. Yeah. You see it. It's like headless net.
So the 0 x2, yeah, doesn't work if there is an x. Like
If there was an x² here, yeah, then you would just, you would have used that number.
Okay.
Correct. Yeah, as you do problems 2 and 3, you'll see that show up.
Yeah.
Remember, hold on. What's up?
So you want to look at the same. This is degree 2, degree 1, and constant degree 2. Versus. Look at the second. What's missing? But which, how is it missing? Well, there's a degree, there's x², so that was not missing. Is there an x³? So that was missing.
You're assuming that like all the terms have been combined together. So there wouldn't be another x².
Is it because they have to be the same number?
Correct.
So if it's the x⁴, there has to be the x³.
X².
X².
X, correct, that's why. Correct, yeah.
The X is at the bottom was.
You flip them because those are what make, like, what are the considered the roots of these guys. It's what makes this equal to 0, yeah, so that's why it's.
So I don't know if I'm doing something wrong, because I know it's supposed to equal 0.
So. Write this down.
Multiply it 3 times 6. Right. Counter
You
one?
didn't include the negative signs.
Oh, oops.
Yeah, bring along those negatives.
Where did these zeros come from?
I'm gonna go over that, okay, but I'll just answer your question. Like, let's say this had a 7. That tells you that f of x is this times this plus 7. So, okay, let's watch. This is degree 4, right? If I write it with this notation that we learned. This weird notation that is. Guys, for number 2. For number 2, this is degree 4 polynomial, right? So the general way of writing a degree 4 polynomial is something like this. Okay, how many terms should be there total? 5. But this one only has 3. So 2 of them have to have 0 coefficients. I'll let you guys think about which ones. Right? Be careful. Once you finish dividing them, I want you guys to practice writing it like this. What should the top polynomial factor? What would it look like? So you're gonna bring them back.
I don't know. And how to write it in class, I can write it in another one, so like, basically, you have x equals 3x2 plus 1.
So you always know that it's something, you're gonna start with one verse.
Oh, no.
Like. So you see this. You're only letting you know. This one, right, it's the one. And if this is 3x,
And then.
everything is one. So.
So minus.
Let me give you guys a heads up so that I don't get 1,000 emails from WebAssign. And it'll be on the recording in case you forget. Okay, WebAssign's a little weird in how you enter this, okay? So look. I'm a student right now and I'm doing the homework on this section. So the first ones are, confirm it's a root. Like we did. Here's my polynomial, my equation set equal to 0. Which ones are the roots? Write the smallest one to the biggest one. But then it also says, what's the multiplicity of the 0? Let me remind you what that's about. So for example, what makes this equal to 0? 5. What's the multiplicity of that 0? 3, because let me remind you why. Because that x minus 5 is cubed, correct? So it's really x minus 5 times x minus 5 times x minus 5. So it's a root 3 times. That's what we're calling the multiplicity.
And if there's nothing, like if it's not like squared or.
Yeah.
Then it's just.
Whatever that exponent is, yeah. Yeah, Rohan. The multiplicity of the root corresponds to the power of its linear factor. Yeah, but yeah. Okay, but then I want to go down towards the bottom. Okay, see here, this is what you're doing right now with synthetic division. It says use synthetic division to find the quotient and the remainder. So for example, oh, right here. When I did this problem, see how we got remainder 0? So I would put the remainder there. 0. And then here, I'm gonna put the g of x that I got. Okay? So I would put whatever, when I do synthetic division, I'm gonna put here that polynomial that I get, and then the remainder 0. And then it's gonna say it, see, this is complicated, but it's saying write it in factored form. So then you would put, I'm dividing it by x minus 1. So I would put x minus 1. And then parentheses, whatever I got here for my g of x. That answer right here. Yeah.
And for that, answer, that's to do whatever, so if x student is x1 is going to be considered as x1 has to be 1.
Yeah. Yeah. Question. Because remember I told you this section actually covers a lot more theory. They cover what happens when the remainder is not 0. I'm not gonna go there though. But the homework is designed for problems where the remainder might not be 0. But I'm only giving you ones where the remainder is 0 because that's what I want to focus on.
Does that one have 12 on it? 'Cause there's like a pack one.
What do you mean by
Like you just scroll up. Never mind, because like when they have the practice and other, sometimes you can do that and just kind of put something.
Oh, to practice, yeah.
And then show you what they're looking for.
Yeah. Mhm. Yeah, but it was this part that I want to show you guys, so you don't get freaked out, so that you guys know how to enter your answers, okay? Okay. All right, let's keep going.
Hold on, we're still always. The next number from 0, no matter what.
Uh-oh.
Oh. This one will, this one. So we do here, we do like. So this one is the, the last one, this would have.
Yeah. Okay. Okay, that makes sense.
Yeah.
Still big.
And then you just square it out. Because you know how you get the f of x and then you square it out.
Yeah, I mean, if you're trying to find where the zeros. But like, to find g of x. It's like, it's.
Yeah.
It's not more.
And then that one, you just brought down the bottom of the equation and then just brought the g of x.
You put 0 in the top, right?
Yeah.
6 is 5. And go from there. Before the line, and then. So the universe.
Yeah, I don't think it is because we have to.
Or do I just?
Kind of, but both give us. So like if you want to factor it out, you see how it's that could give us 5 and 6, right?
Oh, so that, yeah, so that's.
So this one, I don't think there's anything that would give us.
You would
exact-
have to do it. Okay. Everything drops to the. And then. Correct, but we don't even care.
Yeah, okay.
If it doesn't. Factors that makes.
Yeah.
So if you don't put things to it.
Yeah, because it, so it's just 3x plus 1. Yeah. So we have to use the x, either x squared, right? Because like. X squared, I think it was the x squared.
Because you don't have to go to this.
Yeah.
If you know the degree three. So we multiply this cube for it.
Uh-huh. Oh, so there's already x squared, it's x cubed.
There's two.
So x cubed and x. Oh, okay. So it would be. X4 subtract x 0x cubed. Subtract x2, subtract x. And subtract. Wait, what? He did it. Wait, you got it too? Never mind, that's all. Yeah, too. It's a two. You got a point.
Sorry, I said. Oh, okay.
Oh, never mind, never mind, never mind, never mind, never mind. He broke down the equation, what dumbass. Okay, does this look right? So it's kind of squished, but I don't know if it's happening.
Yeah.
I try to do like, come and get it, like lay it. What?
Because minus x is the same as saying minus one x, but really it's zero, zero.
Yeah.
You can check your answers here.
Want me to take care of it?
Okay, let me give you guys some helpful tips, okay? Let's start here. If I ask you guys what degree this polynomial is, what would you say? How do you know that? What's the highest power of x? Highest power of x? For this one.
Oh.
It's gonna be one. Okay, so this guy here is degree is equal to one. What's the degree of the one on top? 2. Okay, notice this is degree 2. This one's degree 1. So your g of x is gonna have to also be degree 1, because when you multiply these together, then it will give you a degree 2. So what does that mean?
Oh,
That when you divide your polynomial on the top by a linear factor, your answer that you get should drop 1 degree. Let me show you what I mean here. What degree is the top? Degree 3. So when you divide it by a linear factor, your answer should be of degree 2, because it drops a degree. Okay? Because this guy's degree 1. And a degree 1 times a degree 2 have to multiply in such a way so that I get a degree 3. So dividing a polynomial by a linear factor will give you an answer with 1 degree less. That's how you know you're kind of like, use that to help you predict what the answer should look like. Yeah, Karen.
Would it work at all with a degree 2?
We're not gonna go there. But yes, and that there, you continue that company with, if you had a degree 2 here. What am I gonna do?
Covering that.
Not at all. Nope.
Is that?
No, it's just, there's so much in the class that I have to find what is gonna be relevant in your calculus.
The degree.
I just gave up.
That doesn't show up. Yes,
For the second one, the answer is partially not much, but would it be x plus 2, x cubed minus 2x squared plus 2x minus 2?
oh shit, I erased it, hold on. It should be, x minus 2.
And then why would it not be 2x? Oh wait, yep, no, I know that.
Yeah. Okay, all right, guys, so all of this is based on, the knowledge that we already know one of the linear factors to help you find that other one. So what we're gonna do on, what is today, Wednesday?
Yeah.
On Monday is, I don't even know what the linear factor should be. How do I even know what root I have to begin with? That's what we're gonna do on Monday. Okay, and then once we find the roots, then we'll know the linear factor, and then we just do everything we just did. Okay, we're gonna end early. We're done.
Yeah, wait, why do? Mark, give me a pen.
I remember when this,